Hi, I'm Mitchell Day, and this is my prototype touch-controlled RC car, the WICar. The WICar is a smart remote control car with a web-based touchscreen control interface. Simply connect to the WICar's network using a phone, tablet, or computer, scan the QR code, and drive. It has two modes, manual and automatic. Both modes are great fun to play with and implement an object avoidance or like a collision detection system. The WICar uses a standard portable battery bank, so it's very easy to recharge and does not need expensive disposable batteries like other cars. So we'll look at the hardware here. And so on the front we have the Raspberry Pi. It's a 3B plus running Raspbian. On the top we have a battery bank, 5 volt, with the QR code taped to the top of that one. On the breadboard we have the L293D chip, which is the controller for the two DC motors underneath that control the left and right wheel. Around the other side we have two LED lights. The green is the status for when the web server and device is started, and the red is when the auto mode is enabled. And on the front is the ultrasonic sensor, the HC-SR04 for the collision detection. So from here we can see how we use it. So using my phone, I pull down my menu, and on Android or mobile, you connect to the WICar wireless network. The system has DHCP, so it will give your device an IP address, and the device, the car itself, is a static IP. That's how we create the QR code for it. Once we've got the WICar connected, you can open up a camera or QR code app, and you go over to the car and you scan that. It could take a couple of seconds. Once it scans, a pop-up will show the website. So click on this, and this will bring up the UI used to control the car. So on it you can see up, down, left, right. Up is forward, down is reverse, left is turn left, and right is turn right. And on the left is auto mode, which we'll explain later. So when auto mode's operated, so we turn that, we click that on, and that will drive forward until it detects, and it'll turn around until it detects there's nothing else, and it'll just keep driving. That will just keep happening until you either press the auto mode to turn it off or click any of the other buttons on the device. So auto mode is turned off once any of the buttons are pressed, even the manual control. So that is how the car operates. So in terms of the architecture for this, we're using Node.js, and Node.js is an event, uses an event loop, or like it's event driven. So it doesn't use multiple cores to actually control separate things. It has an event loop which continues, and any things like functions with callbacks or promises are then passed off, and the event loop keeps going. And then when the callback has got a value, say you're fetching an image, or in this case getting a sensor data distance, it'll do that, it'll send it off. The event loop will keep going for normal operation, and when the distances come back, it will then bring that in as an event into the main loop, and then we can use that in the code itself. So it uses Node.js. It's hosted as a Linux service, so that means that when the device starts up, it'll start the service and the application straight away, and when the application starts, that's when the green LED appears to let you know that the Wi-Fi network is ready, and the GUI is ready to then use as well. The Raspberry Pi is hosting a web server, which does a couple of things. First of all, it serves HTML, CSS, and JavaScript to the client, as we saw with that web interface. It also has a HTTP API, which gets messages from the client and will trigger events, which are your drive forward, drive back, turn right, and brake, which is whenever you hold down one of those to actually start, So when you press the button down, it sends an event saying drive or turn or whatever it is. And when you release the button, it sends another event saying to stop that. The only button that doesn't do that is the automatic mode, where every time you click it, it will switch between either on or off. In terms of the network side of things, I use a couple of libraries or programs called HostHPD, DHCP, and DNS Mask, which are Linux libraries to help create access points and routers. And this is how I'm able to create my own network on the device, which is a better way of doing it, because we know what we're getting. If you try to take this to different houses or different Wi-Fi networks, then you have to somehow connect it to their network, getting the SSID, and then from there try and work that out, and then you have to try and find the IP address of it, and then you have to connect your phone and go through their network. Whereas this acts more like similar things like GoPros or cameras, where they have their own network built in, which is a much easier way of doing it. So in terms of what this product is kind of marketed for, so this would be in the toy / RC car market. How it's different? Well, having kids myself, one of the big things that I find with even the cheaper and even the expensive RC cars, a couple of things is, one of them is, the main one is, they don't last very long with kids driving them. They drive them full ball into everything. So having the collision detection, it does two things. It stops them, it makes the device itself last longer, but it stops them breaking other things or hitting other people. Having that feature, I think, is awesome for kids' toys. Auto mode, that's something you don't have on normal RC cars or toys, but you do have them on things like, obviously, your vacuum cleaners, which, I don't know if you noticed this, but a lot of kids in that are fascinated with when they're going around the house, and animals. So that's a cool thing for them to play around with and chase around. And the last big thing is obviously how it's powered. So a lot of these cars use D's or C batteries, or lots of AA's and lots of AAA's, which are expensive. And more importantly, people leave the car on, which just chews it very quickly. Whereas this one, obviously, it's a power pack. You leave it on accidentally, you just go plug it in and charge it up, and you're good to go again. So that's in terms of how this is different and how it's better in some ways than some of those other toys. Some of the improvements, I've designed a PCB Pi hat, which I will show obviously in the video. On it, it takes whatever's on the breadboard and the sensor and consolidates it. So we have the two LEDs, all the resistors, the L293D, which is the controller chip for the two DC motors, and obviously, I don't know if I mentioned the ultrasonic sensor. So it's all packaged in nicely instead of the cables everywhere, which should make it a bit more robust and compact and easier to fit. I'm using the actual car body is a kit from WICar, but if you kind of compact those with that Pi hat, then you could probably stick it on a smaller car, which would be pretty cool. Other improvements, would be having another sensor, so having one on the back so that it can do collision detection in forward and reverse. At the moment, it only goes forward, so the automatic mode itself, how collision detection works is it drives up to a wall. That collision detection that sensor is every I've got it at 300 milliseconds at the moment, or 400 milliseconds. It will send an event, and then when it receives the value back, it then comes in through a callback, and then it checks. So the collision detection class has a distance and a old distance value. Every time the value comes back, it stores that in distance, and then it compares that distance compared to the old distance. And firstly, if that distance is less than the safe distance we've set, and the old distance is more, then that means it's entered the danger zone. So it sends an event to the car, which stops it being able to drive forward. You can only reverse and turn. It also sends it to the auto mode, because the auto mode, what it does is when it's turned on, it will just say drive forward. And then when it receives an event that you've entered a danger zone, it will then say turn right. And then when it's turned right enough that it receives another event saying, hey, you've exited the danger zone, it will then say drive forward. So it literally just drives forward, stops, turns until it's safe, drive forward, stop, turn. So having two things in the future I'd like to do is one on the back for manual mode collision detection, and possibly even two on the front, measuring the difference in distance on the left and right. So if I come up to a wall on an angle, it can tell that the wall is closer on the right, so turn it left. If the wall is closer on the left, then turn it right. So we can start to turn left and right depending on the angle to the object in front of it. And so they are the kind of improvements I would make on the system itself. Other than that, that is the prototype WICar as it is, and I hope you liked it. Thank you.